This is the first part of the Module 8 lecture. And this Module 8, we're going to learn to test the hypothesis about the population mean and the population proportion. The content of this module corresponds to Chapter 9 in your textbook. All right, our objectives for this module are that you should be able to elucidate the null and alternative hypothesis from the description of a problem. You should be able to determine the direction of the test using the alternative hypothesis. Also, you should be able to explain the type 1 and type 2 errors and their probabilities. Explain the role of the significance level in testing a hypothesis. Explain the meaning of a p-value and its use in hypothesis testing. And finally, you should be able to test the hypothesis of a population mean or a population proportion using what we call the 5-step procedure. And of course, interpret the results that you obtain at the end of applying this 5-step procedure. All right, let's look at the estimation of a population parameter. This is the procedure that we follow when we constructed a confidence interval. And now we're going to follow the same procedure to test the hypothesis. So number one, you need to identify the type of random variable. You either are working with a continuous random variable or a discrete random variable. The next step is to identify the parameter of interest. In the context of this module and in module 7 is that when we work with a continuous random variable, the parameter of interest is the mean of that continuous random variable. If we're working with a discrete random variable, then the parameter that we'll be looking at is the population proportion, pi. Now, once you identify the parameter, you need to identify the estimator of that parameter. So again, if you're working with a continuous random variable, then the parameter of interest is going to be the population mean, and the estimator of the population mean is going to be the sample mean. If we're working with a discrete random variable, then you know that the parameter of interest is going to be the population proportion, and its estimator is going to be the sample proportion, or p. All right, once we've done that, then we need to determine, if we're dealing with a continuous random variable, we need to determine if the sampling distribution of the average is normal, or if the sampling distribution of the proportion can be approximated with a normal distribution. Once you complete step 4, then based on determining if the sampling distribution of the mean is normal, and of course we will not know the population standard deviation, then you know that you will use the t-test statistic. And of course you will use the t-probability distribution. If you're dealing with a discrete random variable and you're trying to test a hypothesis or estimate the population proportion, then as you saw in module 7, we're going to use the normal distribution to approximate the sampling distribution of that proportion. In that case, because we're using the normal distribution, we're going to use the z statistic, and of course we're going to use the standard normal distribution. Once you have gone through this identification part, then you start making an inference about the population parameter of interest. So you will calculate the point estimate from the sample data, either the sample mean and standard deviation or the sample proportion. And once you have that, then we're gonna test the hypothesis for a particular value of the parameter using our sample mean or our sample proportion. And we're not going to do it in this module, but you could, using what we learned in the previous module, you could also calculate the confidence interval estimate for that parameter. All right, so this is the estimation, the procedure to do the estimation. This is important because when you deal with problems, when you're testing a value of the parameter or constructing the confidence interval, you need to know, are you working with the mean or with the proportion? And that is going to depend on whether you're dealing with a continuous random variable, then you will deal with the mean. And if you're dealing with a discrete random variable, then you'll be working with the proportion. So keep that in mind so that you distinguish these two types of problems. All right, so let's look at an example to illustrate what is this idea of hypothesis test. So one important thing that perhaps you're dealing with or your parents are dealing with is the amount of deductible that people that have an employer-provided insurance, that deductible seems to be going higher. So in this example, we're using the information from the Peterson Kaiser Health system tracker. That they said that the deductible for someone that had an employer-provided insurance was $1,077 in 2015. So in a study, 78 individuals with employer-provided health coverage were selected at random to evaluate how much they paid in deductible in 2016, so that's a year later. And here the sample mean or the average of those what those 78 individuals responded of what the deductible they paid in 2016, that sample mean is 1,168. Now the question is, based on this sample result, this 1,168, we would like to determine if the true mean of the amount of deductible paid in 2016 is statistically higher of the average amount paid in 2015. And just for this example, we're going to assume that we know the population standard deviation and that is $350. All right, so in here, we're going to assume that in 2015, the true mean, mu, is 1,077. And he would like to know how likely it is to find a sample average of 1,168 if the true mean for 2016 is 1,077. So here I'm showing you the sampling distribution of the mean, assuming that is centered on the mean of 1,077. That's what we know in 2015. We want to see if it is the same value in 2016. So we're going to assume that in 2016, the mean remains the same. And then we're going to see how likely it is to obtain an average of 1,168 if the true mean is 1,077. So in here, I'm showing you the scale in the values of the average and in values of the mean plus or minus a given number of standard deviations. And so you know that the sampling distribution is normal because the sample size is 78. And I'm showing you the standard deviation of the sampling distribution, which is 39.63. And you see this point is one standard deviation above the mean. This is two standard deviations above the mean. And this is three standard deviations above the mean. And now you see that the observed average from the collected data is 1,168. The question is this a likely value if we assume that the true mean is 1,077? Well, this is over two standard deviations away from the mean. If you think back to the empirical rule, then you know that from two standard deviations below the mean and two standard deviations above the mean, you have 95% of the data. And you have only 5% outside that interval. And because this is symmetric about the mean, then in the upper half, you have a probability of 0.025. So this thing is in that range of a probability of 0.025. Well, the question is then, is this too rare to believe that this mean is correct? And so you can see that this is a little far to believe to be a likely outcome if the mean is this 1,077. So in what comes next, we're going to learn a procedure to determine whether this average is too rare to believe that this is the true mean. All right, so in the next section, we're going to talk about what is actually a hypothesis test of the population. So I want to stop here and we'll continue in the next segment.